Assalamu alaikum warahmatullahi wabarakatuh, everyone. I'm Umar, and today we're going to deal with data analytics and the revolution of the data in IoT, problems we are facing, kind of data we are dealing with, and the storing devices that data will be stored in, where the data processed, and how we deal with this data, and what information do we produce, kind of analytic done on that different types of data. So, first of all, we need to know that sensor does not just measure the world, they digitize it into actionable intelligence. Now, let's head on to the one of the first and the most important problems in the world of data. In our first slide, we're going to talk about the huge amount of data being produced by the sensors. Usually, if you have tens of sensors, that would not be a real problem, but in the infrastructure and manufacturing, for example, a jet engine, we're talking about 500 sensors per jet engine. That 500 sensors usually produce more than 10 gigabytes per second. For a single jet engine, if you make your calculation with 8 hours of flight, that's about 500 terabytes of data per day for a single jet engine. So, just if you calculate it, most of the planes have two engines. That is 1000 terabytes. The problem is where we are going to analyze that data, where we are going to store that data, which we're going to talk about in the next slide, what forms data we are getting, and the problem of that usually these data are useless and have no any impacts on the flight. Another example is your car, especially the modern one. Could you expect how many are on the roads now? What's the amount of the data being produced by those cars? Take a minute to search about that. And in the next slide, we're going to talk about the storing of the data. Data in our case could be classified in two main ways, whether it's being transmitted in motion or at rest stored in the cloud or at the data centers. On the other side, we have the structure and the unstructured data, whether the data is in a format with a schema, and it could be simply stored, and it is easier for the analyzation process. And on the other hand, we have the unstructured data, which has a lack of logical schema and need to be instant filtered at the motion unit. Uh, while at the rest, the unstructured data uh, makes up to 80% of all the business data. And structured data are usually the videos, audios, text, and so on. In my case, for an example, the attendance at Mr. Said lectures is an example of the structured data. Any cross between the column and the row would lead to the information of one of the random students. On the other side, an example of the unstructured data is the videos in the cabin of the airplane or the audios being recorded in black box at the plane. Now we have the four types of analytics. First of all, we are going to talk about the descriptive. What's going on in my system? In our example, we have the truck engine temperature is rising. There's many other examples. It's not only considered in that kind of systems. So after that, we have the diagnostic analytic. Why did that thing happen? It's usually simple question which being asked to find the cause of the problem in your system. In our example, we have the engine overheat due to the broken fan. Next, we have the predictive. What will happen in the future? Based on the historical data, this fan will fill in 3 days. That means we're going to get again the overheating of the engine. Next, we have the prescriptive analytic. which means how could I deal with the future problems to avoid them, to avoid bucket rolls on my system. For an example, just change the fan of the truck in the nearest service center. That kind of analytics is a high value and a high complexity. You need to use Python algorithms, you need to use many types of SQL and BI tools for the analytic. Now, after processing the data, in some cases, you need the help of the algorithms using the machine learning. Mainly the machine learning have two types, the supervised and the unsupervised. There's many other types, but it's beyond our lecture for today. First of all, we're going to start with the supervised learning. Classification, it's based on classification and regression. The machine will be trained on a clean, labeled, known data. And after that, the machine should have the ability to answer a question related to that kind of data to label by a yes or no questions, to label by an average questions for the types of data. Next, we have the unsupervised learning. It's a kind of clustering, grouping the data. So it finds the patterns, sees the pattern in the data, and collects each similar patterns in a group. So for an example, we could use that to know the sound of the broken engine from other normal engine. Mainly, as you could see, the supervised learning focus on the structured data, and unsupervised learning usually deals with the unstructured data. Now, if the machine learning was not enough, we don't need a 0, 1 values. We don't need yes or no questions. We could head into the deep learning and the neural network. First of all, in our example, we're dealing with a dog case. We're entering the raw image. First layer of nodes will shape the edge of the photo. The second layer will combine it to see the real photo, shape, face, and limbs. And at last, it will make a high complex concept, and then the output of the system is calculating the probabilities of whether it is wall, dog, cat, or whatever in the photos. Now, dealing with deep learning is a huge amount of data to be trained on, and if by any way the layer was more than the deep learning need, it will lead to the overfitting, which means the failure of the system. Now, the end of our data journey. The data could be stored in the IoT mainly in three places. Relational databases, which contain the structured data using the SQL language to deal with. It's great to take the sensor data, ever sensor data. It's preferred to not fill it with a huge amount of data. Next, we have the NoSQL databases, which contain the semi-structured and the unstructured data. It's more flexible and evolving schemas. And last, we have the Hadoop for big data. It's a massive distribution cluster servers. Usually, it uses the HDFS for storing a petabyte data across multiple nodes. Now, we have two important questions. First of all, do we analyze all of the data at the cloud? And what if we need an instant response to a critical? The answer is no. Actually, we have too many places that the analyzation of data take place, either in the sensor or at the cloud. First of all, at the sensor, we call that an edge streaming analytic. Uh, the value of that or the benefits of that, it's reduce the value and the amount of data being transmitted to the cloud, enable the instant response to a critical and the time sensitive events. On other side, we have big data analytic, which take place at the cloud. These kind of analytic is a deep analytic, use the historical analytic for a long-term strategy insights. For an example, on a case, we have Formula One racing car. In split of second, we need to brake to avoid going out to the track. On the other side, we need to find how was the performance of the driver on the whole season that could take place in the cloud. Now we have a special type of analytics that take place in the network at the transmission of the data. Network analyzation does not means that we're going to read the payload necessarily, but actually it focuses on the flow of the traffic to define the normal behavior and the suspicious. Actually, what it focuses on is the source and the destination IP address, traffic volume, and the TCP UDP port. But what does it matter? Here's come to instant detection of the suspicious traffic at the sensors. For an example, a sensor says 1 kilobyte of data per day. If that sensor is suddenly streaming 1 gigabyte to unknown address, that kind could be a cyber attack, and likely it is a DDoS. And on the other side, it could be a kind of sens- sensitive data leakage that could lead to a loss in the business. And now we can actually see the big picture starting for the raw data produced by the sensor going to the instant action by the edge analytics and the filtering to make an immediate response. The storing the data in different types of storage depending on the type of the data, and after processing it, feeding it to the ML, deep learning, and the neural network. After that, the optimization to improve the behavior of the sensor itself. The main point that you need to take with you is that the goal of the IoT is to build a compatible system that have a self-healing and self-optimization. Omar was with you. Thanks for watching. Have a nice day.